Hello everyone, in the last video I explained what happened in the Big Bang, but today I'll show you how every element was made and its processes that it went through. So I'm gonna do a quick recap about the Big Bang. There was a singularity and it decided to expand faster than light. The singularity was too hot for anything to combine, and as the universe expanded, it got a little colder, cold enough for something to happen, but hot enough for all the subatomic particles and the quarks to combine, and thus all the other things we see in the universe was made, like the stars and the black holes. From the Big Bang to the death of a star, we get all the elements we have, and I'm here to explain it, so let's pull off a Jimmy Neutron and got a blast! So yeah, the universe was hot, but as it expanded it got colder, but it was still hot for all these subatomic particles to combine. Once these quarks combined to make a proton and a neutron, they decided to combine and make the first light elements. So this is how the proton or hydrogen atom is formed, while this one is how the neutron particle was made. Now both are important, but the next stage has two protons, which is helium, so I'd like to give more attention to protons, but both are equally important. Here's a rough sketch of what our universe looked like. Yep, it's just gas. But it got boring, so this hydrogen absorbs some neutrons to make hydrogen 2, also known as deuterium. You know, nothing special, he thinks he was too cool for school. Then deuterium was like, whoa, that's kinda cool, I wanna do that. So they combined to make helium and its isotopes. So there was also a few traces of lithium when the Big Bang happened. Now you're probably thinking, or not, that whoa, that's kinda crazy. But hold your horses, cause it gets even crazier. Remember that our universe was just a bunch of gas? Well, there's a strong force pulling these gases towards one another, until it got so compressed that it flings all these space dust out and make a star. Stars are really interesting, since they need to balance out the gravity which is pushing them towards one another, and the outward force of the thermonuclear reaction made by hydrogen-hydrogen fusion. Speaking of thermonuclear reaction, here's a rough scenario on what happens in that star. Hey, wanna get married and like be one or something? Yeah, sounds good. And that's what happened to the first star. It fuses the atoms, in this case hydrogen, to make helium, and if the star is massive enough, it does this process until it hits iron 56. By this stage, this red supergiant, not to be confused with a red giant, like your typical senior high school student, collapses under the natural pressure, in the case of the sun, gravity, and in the case of students, just generally being alive. And it explodes because of this imbalance, and creates a supernova, and this makes all the other heavier elements. After this explosion, there are two outcomes of this supernova. Either it becomes a neutron star, an extremely dense star where if you were to get a neutron star the size of a sugar cube, it would weigh 1 billion tons, or roughly the weight of Mount Everest. Or you get a black hole where not even light can escape it, and breaks our laws of science, both of which are extremely interesting. Anyway, that's all the time I got left. I'm Peter Menge, and thank you for watching.